Well, the standard normal distribution is one of the most important distributions in all of statistics. The standard normal distribution requires the mean to be 0 and the standard deviation to be 1. Most of the time, that's not the case. Most of the time, we just have a general normal distribution that have their own mean and standard deviation. So one way to get around this problem is we can standardize a normal distribution with a mean of mu and a standard deviation of sigma. So the mean's something different, the standard deviation is something different, but it is still a normal distribution. It still has that curve to it. The way we can standardize it is with the familiar formula we have for z-scores, that we take the value that we're interested in, subtract the mean, and divide by the standard deviation. So for example, if final exams were normally distributed with a mean or average score of 78 and a standard deviation of 6, we could find out the probability a random student scored less than 80. Now, visually, what we're talking about here is we've got some normal distribution where the mean, the middle value, is actually 78. We'll call that an x value. And we want to know what is the probability they scored less than 80. 80 is off here to the right. We want the probability they scored less than 80. We want this area to the right. Well, one way we can do that is, instead of working with x values, we're going to standardize this and convert the units from final exam scores to a standard normal curve where 0 is in the middle and the standard deviation is 1. The way we do that is with that z formula, where we say z is equal to the value we're interested in of 80, subtract the mean of 78, and divide by the standard deviation of 6. When we do that, we get 0.3333. So that means the corresponding z-score for 80 is 0.3333. Now that we know the z-score, we want the area to the left. We know on Excel we can find the area to the left using equals norm.s.distribution. And the z value is 0.3333. And we type in true. When we do that, we'll end up with an area of 0.6305. So scores less than 80 occurred about 0.6305, or 63% of the time.